Hello.
All right, hello to you, class. All right, so we're going to look at volume of a cone today. Here's the formula at the top, and I want to explain where this formula comes from. So we're going to draw a little picture, and if you're like me and you're a little bit artistically challenged, it's okay. We can get through it. So we're going to draw a cylinder. So we're going to draw like a little oval like this with some lines that should be the same length coming out of it, a little curved base, and then I'm going to show the little line that you wouldn't see that's behind, okay? All right? Now, this lesson isn't about cylinders, so where am I going with this? We're going to say that we're going to take a point in the middle of the circle at the top of the cylinder, and we're going to cut a cone out of the cylinder so that the base of the cone is the same as the base of the cylinder. It has the same height as the cylinder, but we've basically cut the cylinder into 3 pieces. So this little cone in the middle is a third, and there's a third here and a third here. That's where the 1/3 comes from in our formula for the volume of a cone. It's like the middle third when you take the cone out of the cylinder with the same base and height. Okay, I know you were all thrilled. So let's just move on. All right, so we're going to use the formula. Basically, this is the cylinder formula. Pi r squared is the area of the circle times the height. And then we're just taking 1/3 of it, okay? So on this first part, it says, find the volume of each figure. Round your answers to the nearest tenth if necessary. So this cone is set on its side. So we have to sort of imagine it turned this way, okay? So the radius is 5, and then this 11 would actually be the height. So you have to sort of turn it in your mind. I kind of tried to draw it. It's really bad, but you can sort of see what I'm trying to draw. So our volume would be 1/3 pi r squared would be 5 squared times the height, which is 11. So I'm going to show you 2 ways to put this into your calculator. All right? So if we want to just use it the way it is with the 1/3, you could do 1 divided by 3, and then just hit times. We're going to use the pi key, which is above your power key, times 5 squared times 11. So I just typed the whole thing in. We get 280. Oh, actually, let's look at this. So we're going to round up to the nearest tenths, which is this 9, but there's a 7 next to it, which makes that 10. So it's going to round up to 288.0 centimeters cubed because it's volume. So we should have cubed on the answer, okay? So that's one way to type it in. I'm going to give you an alternate way. You could also type in pi times 5 squared times 11 and then just put divided by 3. It's slightly less typing. It'll get you the same answer. So dividing by 3 is the same thing as multiplying by 1/3. You can type it in however you want. If you just want to do it straight like the formula says, it works. Our graphing calculators can handle that.
Yeah.
Okay, so let's go on and do the next one. So on number 3, I need the radius for my formula, but I have the diameter.
10.
So that means that my radius for this would just be 10. We just went halfway across, okay?
Yeah.
So then we're going to do 1/3 pi times 10 squared, and the height of the cone is 20. And we'll just type that in. So 1/3 times pi times 10 squared times 20 comes out to be 2,094. And if we're looking at the decimal, I have 0.39, so I would actually round that up to 0.4. We're measuring in centimeters, so this would be centimeters cubed. Okay? So if they happen to give you the diameter all the way across the circle, remember that you just need the radius, which is halfway. All right, let's go down and look at number 4.
Colton.
All right, so for number 4, we're going to have 1/3 pi. What's the radius? So this is already just halfway, so we go ahead and just use 2 because it's only halfway. And the height is 11. So type in 1/3 times pi times 2 squared. 2 squared. I forgot the squared. 2 squared times 11. So if you forgot the squared, just take it times 2. And we end up with 46.07. So if we're rounding the tenths, that'd be 46.1. And that'll be centimeters cubed. So that's how you do it if they give you the picture. Sometimes they're going to give you a story problem. You just pay attention to whether they give you the radius or the diameter. So this one says a cone with radius 5 meters, that's R, and a height of 11 meters, that's H. Just put it in the formula. So 1/3 times pi times 5 squared times 11. 1/3 times pi times 5 squared times 11. So we get on the calculator 287.97. So I'm rounding to the tenths. It'll come out. Oh, this is very much the same thing as this one up here. I wasn't getting what you were saying. So this was randomly generated by the computer. So this is going to round up to 288.0 again. Oops. It's meters this time instead of centimeters, so I guess that's different. But just basically, I wanted to have an example where you had to take it out of a sentence instead of out of a picture. All right, so on the next part.
On the last one, you said 1/3 times pi.
Yes.
Would it be any different than just putting 1/3 pi? Or would it be the exact same?
I'm not sure. It depends on whether the calculator is interpreting it as 1/3 pi and putting the pi down here. I always just put the times sign in to make sure.
Okay.
It depends on your calculator, and I don't remember how those do, so I just go ahead and put the times in.
Gotcha.
All right, so let's look at the next part. Find the volume of each figure. Round your answers. Oh, this is actually not supposed to be there.
Yeah,
The directions got changed down here, but I didn't get that part deleted. Sorry. So it says leave your answers in terms of pi for answers that contain it. So when we do this, we're going to have 1/3 pi. What's the radius?
5.
5. So 5 squared, and then times the height, which would be 10. And if you're leaving pi in the answer, we just multiply all of this and leave the pi out of it. So on the calculator, you're going to do 1 divided by 3 for 1/3 times 5 squared times 10. So we didn't hit the pi at all. We get 83.33. Maybe that's what the hundredths was about. So it's going to be about 83.33 pi, and then you could put feet cubed. So they just left the pi in the answer. They do that a lot of times if this comes out a whole number on your standardized tests. If this had come out to be something like just 81 pi, you might have been able to do all of this without a calculator, and so that's a lot of times they'll leave the pi out so you can do the math quickly if you're on the section without a calculator. All right, so let's look at number 7. So it's 1/3 times pi. What's the radius? 5. Oh my gosh, times 11. That's the same problem we just did up here. So, well, at least we know what it is. 288.0 inches cubed. So I need to regenerate some of these so it doesn't give me the same problem 3 times.
Yeah.
Oh, and pi.
Yep.
So it won't be this. You're right. That would be my decimal answer, not pi. Good job. Way to pay
Good job,
attention.
Sophie.
So what we're actually going to do is 1/3 times 5 squared times 11. So that comes out 91.6, repeating. I'm rounded off to 91.67 pi inches cubed. So it is the same problem, but they wanted the answer in a different form. All right, moving along. Story problem. Assuming you can fill it to the top, how much water can a paper cup hold that has a diameter of 8 centimeter inches? I think I meant centimeters.
Our cups.
And is 10 centimeters tall. So we're saying it's a paper cup, so it's 8 centimeters this way, and then I'm going to make it a really shallow cone here to draw my picture, and then the height is 10 centimeters. So what's the radius that I need to use?
4.
4. So we're going to have 1/3 times pi times 4 squared times 10. So let's put that in. 1/3 times pi times 4 squared times 10. And so that comes out 167.6 centimeters cubed. And then it says, if you poured a 2-liter bottle of soda out into these paper cups, how many could you fill, assuming you fill to the top? 1 cubic centimeter is the same thing as a milliliter. So think about a 2-liter bottle. So a 2 liters is how many milliliters?
7.
How many milliliters are in a liter?
2.
1,000.
1,000. So that 2-liter bottle of soda is 2,000 liters. And we're trying to figure out if I poured that out into these cups that hold 167.6.
Milliliters?
So milliliters, yes. Which is the same thing as cubic centimeters. So I could also call it 2,000 cubic centimeters. Same thing. And then I want to see how many of these cups we can fill with this. So what would we do?
Divided.
Divide. So we're going to divide this by the 167.6. So 2,000 divided by, I still have my answer on there, so I'm just going to use my answer. And it's, actually I'm going to try it with, so it comes out about 11.93. So we'll say almost 12 cups.
I would just say that.
So you could fill 11 to the top. You could almost fill 12. There's different ways you could word that. Just make sure you have this on your page. All right, practice problems. So turn over to your practice page. We're going to draw a cone. Are you ready?
It's been so long.
To draw a cone,
Practice problem.
you do a little ellipse down here. It's supposed to look like a circle from the side. And then we're going to put like a little party hat shape on top. All right? So we're going to say that the radius of this is 12 inches. And let's say that the height is 15 inches. And I want you to find the volume.
With pi.
With pi in it, yes.